Welcome to week 9 in Introduction to C++. And this week we're going to do a quiz. We're going to talk about functions again. We're going to continue talking about functions. We covered them last week a little bit. And this week we're going to get into some more nitty-gritty stuff, function prototypes, recursion, and header files. And then we have a quiz this week. We have an in-class lab, and then we have an assignment due next week. So it is a heavier class for asynchronous work, but it'll be really good for you guys to get comfortable working with functions. And the assignment is based on an assignment you've done in the past, so it shouldn't be too difficult because you'll already have a starter template to start from, and then we'll just continue from there. Okay, cool. So we're going to start with the test this week. We're going to start with the quiz. It's the week 8 recap quiz from last week. So you can just click this link. I'm in the weekly learning week 9 folder on Blackboard. If I click this, it'll just take us to the test. And the password for the test is November test 1, all lowercase, no spaces. November test 1. And I'll put it in chat just like this. NOVEMBERTEST 1, all lowercase, no spaces. Put that in and let me know if it works. Okay, cool. So it's got a time limit of 25 minutes and it's got to be completed in one sitting. The timer will not appear when previewing the test, but once you've actually taken it, it will start. So you can save it and resume it at any point until the time is expired, and it is due tonight at midnight. So if you guys are watching the recordings, please do it as soon as possible. And yeah, let's get started. Let me know if the password didn't work for you guys. If I don't hear anything from chat, then I'm assuming that the test password worked. Works for you. Cool. That's great. Okay, so let's get started with question 1. A function prototype must include all of the following, all but one of the following. Okay, so we've got name, so a function name, a semicolon, names for any parameters, and then a return type. What do we think? So all of them are necessary except for one. There's one outlier that doesn't actually need to happen when we're making a function prototype. Now, we covered function prototypes briefly last week, but we're going to get into them a bit more this week. So if you don't know, that's totally okay. We're going to cover them this week and make sure that you understand how they work in C++. But return type, a return type is not necessary if it's void. Okay, that's true. That's true, but let's assume that this function does return something. And technically, even if it is void, that is a return type in it of itself, right? So when you write the function, you say void function name parameters semicolon, right? So we've got void, which is our return type, so we know that that's there. We've got our function name, so that's the next piece. So we know that that is necessary. You can't have a function without having a function name because we could never refer to it. So then we've got our parameters. But is that optional or is that a must include? Right? What if our function has no parameters? What if there's no arguments we need to pass? And then a semicolon. Obviously, we know in C++ you have to end everything with a semicolon, so we can kind of deduce that that's not it. Got it. Nice, Fatima. It is names for any parameters. Perfect. Very good. Okay, so you don't need to have names for your parameters in the function prototype, and we're going to talk about that a little bit later today. So don't worry if it's a little bit confusing, but parameters are optional in functions. Perfect. Right, but that would still be a name, Simon, if it was stored in a variable, right? So if you had it stored in a variable, then you still have to give the function a name. You can't have like you can't have an anonymous function like in JavaScript. In JavaScript, you can make a, yeah, but if it's a variable, then the variable will have a name, yeah. So we do need a name when we're creating a function. Okay, moving on to question 2. A local variable is a variable that's defined outside of any function, within a header file, or within any block of code. Yeah, okay, cool, Simon. Sweet. If there's any other questions about the last question, please, like I would like to talk about them now, and then we can discuss them. If we're good to move on, we'll move on. But if there's any other questions, I'm happy to answer them. We will talk about it a little bit later today too, if there's still some confusion. But so we think within any block of code, any block of code. So you think it's within any block of code or within any function? We've got kind of both. We're seeing both. Radhen and Bura are voting for block of code. Simon and Fatima are voting for within any function. So the correct answer for this one is within any function. Yeah. It's close though. Obviously, if it's outside of a function, it's going to be a global variable, right? If it's outside of the main, but obviously, if it's a local variable and it's in an if statement or an if block of code or something like that, it's still within the main function of that program, if that makes sense. So it's still a local variable. Very good. All right. Question 3. Why is the following function declaration invalid? I'm going to see if I can zoom in a little bit for you guys here. Why is the following function declaration invalid? So we've got a function called double. So it returns a double. It's called calculate underscore future underscore value. That's the name. And it's expecting a double monthly investment. So it's expecting a parameter that's of type double with the name of monthly investment. And then it's expecting another parameter that's a type double, yearly interest rate. And it's set a default to 4.5 for the yearly interest rate. So that's fine. It's a double and it's a 4.5. And then it's expecting a third argument, an integer, and it's naming it years. Why is it invalid? A, you can't code default values in function declarations. So they're saying that you're not allowed to do that. B, if you code, whoops, I didn't mean to click it. B, if you code a default value for one parameter, you must code them for all parameters after. So saying if you do it for this one, then you must do it for this one. If you code a default for one parameter, you must code them for all parameters before. So then they're saying if you do it for this one, you have to do it for the monthly investment parameter. Or if you code a default value for one parameter, you have to code them for all parameters. And so there it's saying you need a default value for monthly investment and a default value for years. What do we think it is? Either A, you can't do it at all. B, you have to do it after for every single one. C, you have to do it for every single one before. Or D, you have to do it for all of them. If you do it at all, you have to do it for all of them. You think B, Fatima? Simon says if you code a default value for one parameter, you must code them for all parameters before. Radhan thinks after. Okay, so we've got a bit of a debate between the before and the after. So the correct answer for this is after. So once you do one, so we made our double yearly interest rate default to 4.5. Every parameter after this, so years, would have to have a default set. Perfect. Okay, good job, guys. Nice. Okay. Question 4. When you use a reference parameter with functions, your code is more efficient because, and we kind of talked about this in our morning debrief review, recap. when we use reference parameters, remember reference parameters are using that ampersand symbol. When you hold shift and hit the number 7, you have that and symbol with your variable. A copy doesn't need to be made, is what Radhan says. Fatima says what the answer was for the last. What was the answer for the last one? Oh, can I go back? I think I can go back. Question 3. It was if you code a default value for one parameter, you must code a default value for all parameters after that parameter. Nice. Thanks, Jillian. Okay, so Simon also is saying a copy doesn't need to be made of the value that's passed to that parameter. So you guys think it's this one. And you guys got it. Yeah, exactly what we talked about this morning. A copy doesn't need to be made, so it's more efficient, right? Obviously, your code being not efficient, that's not the answer. Your function can't change the value of the reference variable. That's true. The function can't change it if it's made as a const, but it can change it if it isn't a const. So that's obviously out. And the parameters can be defined as constants. Yeah, that's fine, but that doesn't mean that's why it's more efficient. It's because a copy doesn't have to be made, so it saves memory allocation in on our system. Okay, question 5. Which of these statements could you use to call the following function? So we've got a function here. It returns a double. Okay, so we know that its return type is valid and it returns this Celsius double here. Then we know its name is 2_Celsius. Double Fahrenheit is the argument that is expecting. So when you call it, it expects a double to be passed into it in the brackets. And then in the function, it basically takes whatever double was passed to it, minuses 32 degrees, times it by 5/9, and converts it to Celsius, saves it in this variable, and returns it. So it's basically a very simple conversion function from Fahrenheit to Celsius. How would we call it? Which of these statements could we use to call it? We've got double Celsius equals 2 Celsius 212. So here we're passing number to it. We've called the function and we're setting it to another variable. Here we're passing out to the console whatever is returned from our function and passing it 212 Fahrenheit. Here we're passing out whatever was returned to our console, but we're passing 212 as a string. Here we can say all of the above, or here we can say A and B only. Simon says B. Simon says A and B. He updated his answer. Radhan says A and B. You guys got it. It's this one. Obviously, we're saving what we are returning as a double. In this case, we're saving it into a variable. In this case, we're outputting it to the console. And we're passing, this is actually technically an integer, but it's also fine as a double. It's not in double quotes, so it's not considered a string. So obviously A and B are the only correct ones. Nice. Okay, question 6. Which of these function declarations is not a valid overload for the following function declaration? So what is an overloaded function? Let's start with that. What is an overload? What is an overload function? What do I mean when I say overload? You guys are Googling it? So an overload function is basically, oh, here we go. We've got a function, but having the same function, same name, but different parameters. Right, you've got it, Radhan. So yes, Fatima, close. Same name. It can be same parameters, but different types. There just has to be something different about it. So different parameters, different parameter types. Yeah, you got it. Perfect, Fatima. So here we've got a function called, oh, I should probably also, sorry guys, I keep forgetting to do this for you, is turn my, my cursor highlighter on. Just get it running here. There we go. Get my cursor highlighter on so you can see. Okay, so we've got a function here called double calculate _mpg. So it's our mile per gallon calculator. And we're passing it 2 arguments. We're passing it 2 doubles. One is miles, one is gallons. So We've got a function, we pass it two doubles. So which one is not a valid overload? So here we've got a function and we're passing it two ints. So there we've got different parameters. So that's how we defined what an overload function is, right? So here we've got two ints, so different parameters. So I would say that's an overload. Here we've got the same function, but we've got a double, and an int. So that I would say is a valid overload because you're using the same function name and these are the same, but you've added a third one so that you can actually do different programming logic in that function. Here we've got the same name, same return type, and we're passing ints instead of doubles. So obviously, yes, D, we've got the same function name, we've passed the same argument, so there's nothing different there, but we're returning a different type. And you can't do that. You have to have the same return type if you're going to overload a function. So this is the non-valid overload, okay? So all of these are valid, but D is the incorrect way to do it, but the correct answer for this question. Question 7. Okay, what is the value of the variable total1 after the following code is executed? So let's look here. We've got a double variable declared called total1 equal to 40.50. Then we create a reference variable called total2 and set it to equal total1. All right, so it is now going to be whatever the memory in total1 is. Okay. Then we set total2 equal to 42.25. What will be the value of total1 after the following code? So after we set the reference variable to a new number, okay, so this was originally 40.5, then we made a reference variable and updated the reference variable to 42.25. Will it update total1 or will total1 remain 40.5? Will total1 be set to 0? Will it be set to 82.75? Or will it be set to 42.25? We've got a couple different answers in the chat here. Think about it. If you're quick enough to write the code, you can try writing the code in your IDE or pause the video if you're watching after the fact. Oh, we've got a split vote here so far. We've got 2 people thinking it's 42.25 and 2 people thinking it's 40.5. Interesting. So because it's a reference variable and it is set to basically be the value of total1, it means the value of total1 will also be the value of total2, right? They're the same thing. So if we update total2, it actually does update total1. They're the same address in memory. Basically, we set this total2 to be this. So this is also going to be this. They're the same thing, basically, right? So it will actually update it to 42.25. Very good, everyone. Very good. It's a confusing one. That's a tricky question. Question 8. Which 2 statements would you use to call the function that follows? Okay, so we've got a function called 2inches. It's got a reference variable. So we can see it's got a reference variable with that symbol. And it's expecting a double, okay? With centimeters, we're doing multiply equals. So centimeters equals centimeters times 0.39. So we're converting it to inches here. And then we use the round function from the C math library and then times it by 100 and divide it by 100 so that we've got a nice even number. Excuse me. Okay, so which 2 statements would we use to call the function? So each of these answers has 2 statements. So we don't have to select 2 of these. Only one of them is correct. Okay, so we've got double measurement equals 2.5, measurement equals 2 inches measurement. So what would happen here is we set a variable to measurement and equal it to 2.5. Then, because this is returning a void, okay, they're setting whatever the return is from here to that variable. So that actually wouldn't work because it returns a void. The return type is empty. We can't set the left side of the function to anything. right? That wouldn't work. So we can pass it the number, and when that number 2.5 gets entered in here, it's going to be times by this decimal and then converted to centimeters, and that's fine. But because it's a reference variable, we don't need to return anything, right? So that's incorrect. We've got someone voting for this one, I believe. Yes, so someone's voting for this one. So let's look what would happen with this. So we pass a reference variable called measurement to 2.5. Okay, so it's a reference variable, and then we call 2 inches function passing 2.5. So it's passed in here, and it's set to another reference variable, centimeters. So what would happen here is the measurement variable, 2.5, would now be set to the reference variable of centimeters, but then we wouldn't be able to actually, what would happen is it would set centimeters to measurement. Because they're both reference variables, it wouldn't work. Okay, so let's try this next one. We've got another reference variable, so right away we can see they're returning a void type to a variable, so that wouldn't work. And they're using 2 reference types, so that wouldn't work. So then this last one is what a couple of people said here. Very good. So we're passing a variable of 2.5 in, setting it to this reference variable, centimeters, and then we call the function, right? And then it updates it, and then we could use this because it would be updated. So this is the correct answer. You got it. Perfect. It's a tricky one. Okay. The goal of testing. Oh, we've got 5 minutes left. We're going a little slow. The goal of testing is, we'll do 1 minute per question. We already talked about this one, to find all the errors. The goal of debugging is to fix them all, right? So that's a tricky one, but it's to find them. That's what testing is for. Okay, next question. What is the easiest way to deploy a C++ program to a user's computer? Copy the executable file to the user's computer, create an installer program, and then run the installer. Copy the source code or create a batch file. We already talked about this morning. It's copying the executable exe file. Nice. So these are some easy ones to end with. Okay. The default manner in which passing parameters to functions is achieved in C++. Sorry, a user typically I skipped a question. A user typically runs a C++ console program that's been deployed to his or her computer by locating the executable file and then double-clicking it, by using the console to change the folder that contains the executable file and then entering the name of the file, by installing a text editor and then running the program from there. All of the above, A and B only. The easiest way and the way a user would typically locate the executable file is by double-clicking it. Not all of the above, because installing a text editor and then running the program or using a console to change the folder that contains the executable file and then entering the name of the file is not the typical way. So the typical way is just locating it and double clicking it. Cool. The default manner in which passing parameters to functions is achieved in C++ is, okay, so the default. We talked about pass by reference. That's not the default because you have to have that ampersand symbol. What's the default? Pass by pointer, pass by value, pass by reference, pass by name. We haven't talked about pointers yet, so we can take that out of the equation. We take reference out of the equation because we know that's the ampersand symbol. Brewer's got it. Pass by value. Nice. Because it's the value, and if you make a copy of it, you copy the value. You don't copy the address in memory, you copy the value itself. Very good. Okay. I don't know what the time limit is here on the test, but we'll keep going. We've got 2 ones left, and these ones are a little bit tricky. Okay. What is displayed by the following code? So we've got our typical using namespace, we've got a function up here, and then we've got our main function that passes 10, 20, and 30 when we call func. We pass A, B, and C, which have a value of 10, 20, and 30. So in here, we set them to X, Y, and Z. X equals Y plus Z, Y equals 10, X equals 10. And then we return that to the console. Okay. We actually see out A, B, and C from the func. And the func returns void, right? So there's no way, if once these are updated, because there's no return, when we see out, any of these could be changed to 1,000 or 2,000 or 3,000, but we won't get those updates because we're not returning them back to our main function. They're just going to stay inside of here because it's a returning void. So when we see out A, B, and C, it's still going to have the same values of 10, 20, and 30 from our original main function, right? So it's 10, 20, 10, 20, and 30. Okay, and then the last one I want you guys to think about here. So this is the same code, but okay, they're reference variables in here. So it's still return void, but they're reference variables. So they would be set to the variables A, B, and C. So if we change A, B, and C, or X, Y, and Z here, because they're the same thing and they're referencing the same address in memory, if we do update it, it does get those updates in the main function. So what would be the output of the following code? So we pass A, B, and C, 10, 20, 30, into here, 10, 20, 30. So here we're saying 10 equals 20 plus 30, right? 10 equals 20 plus 30. So then what's our first one going to be? 10 equals 20 plus 30. So 20 plus 30 is 50. So then is X now going to equal 50? Okay, so then X is 50. Okay. Then we set Y equal to 10. So we've got 50, 10, and then 30. And then we set X back to 20. So then we've got 20, then 10, then 30. Because we updated X back to 20. We never changed the value of Z. So do you guys agree that it would be 10, or sorry, 20, then 10, then 30? Oh no, the time ran out. My bad, guys. I should see if I can update some more time on it. It would be 20, then 10, then 30. All right. That would be that final one. Shoot, sorry, guys. I was a little bit slow on that today. 20, then 10, then 30. Do you guys understand why that would be that? If you guys don't worry, I'll update the time and the testing if it ran out, but let's just make sure we understand this question, okay? So I can go in and change those settings there, but do we understand how this works and why this is the correct answer? I can annotate a little bit, see if it okay, so we're putting 10 up into here, 20 up into here, and 30 up into here. So then our first one would evaluate to 10, okay, because X is 10 now, equals 20 plus 30, right? Okay, yeah, you got it, perfect. Now our second one, which is Y, okay, which is our 20, we're getting that from here. We're going to say 20 is now equal to 10. Okay, so far, 20 plus 30 is equal to 50. So if we were to save our variables over here, we've got X, we've got Y, and we've got Z. So far, X is equal to 50. Oh, crap. I just double clicked and it erased all my stuff. Okay, so we've got X, we've got Y, and we've got Z. So X is equal to 50. We've got Y and we've got Z. So let me redraw this. We're passing 10, 20, and 30 from ABC to X, Y, Z. So our first one, X equals Y plus Z, is basically saying 10 equals 20 plus 30, otherwise known as 50. Okay, our second expression is saying that Y, which has a value of 20, is now equal to 10. So we take 50, we bring it over here. Sorry if this gets a little messy. We take 10, we bring it over here, so now it's 10. And then our last expression, x equals 20, is basically saying x, which was 10, or sorry, which is 50, okay? So x, which is equal to 50 currently, right, is now equal to 20. So now we scratch this out, we make it 20, and z never changed, right? Z was always 30 from here. So we've got 20 right here, 20, 10, and 30. That's our final updated values, right? 20, 10, and 30. I can change my color so that it's actually a bit better. 20, 10, and 30. 50 equals 20. Yep, you got it. Perfect. Nice. So that's why we did 10, 20, 30. So we can save and submit that. I know you guys ran out of time there, so I'll update that after. We'll go back to the course. I'm going to end the video here. So if you guys are watching this or doing the test after the fact, try to do it quicker. And then I will update the test. We'll take a 10-minute break. We'll come back and get into some of the other stuff that we're going to cover today. So let me just end the recording.